I would like to solve some problems based on Coulomb's law, and we will increase the hardness sorry hardness level furthermore to get good knowledge about the Coulomb's law. Let's take first problem. The problem is the sum of 2 point charges is 7 microcoulomb. They repel each other with a force 1 Newton when kept at 30 centimeters apart in space. Calculate the value of each charge. So, according to given problem, they are repelling each other. It means they both are similar charge. Let me assume that is the Q1 and the Q2. I would like to take both of the positive charge since they are repelling each other with a force, that is the Q1 and the Q2. And the repelling with a force, they are given that the force F equal to 1 Newton, and they are kept at a distance. So here the distance between them, so that I will take as an R is the 30 centimeter is the distance between them, and R equal to 30 centimeter, which is equal to 0.30 or 0.30 meter, since we have to deal with SI unit. And one more value is given that the sum of 2 point charges. Point charges sum means Q1 plus Q2. The sum is given, that is 7 microcoulomb. I need to calculate separately, calculate the value of each charge. What is the Q1 and what is the Q2? So this is the final task we need to calculate. So just apply the Coulomb's law. By Coulomb's law, the force equal to K times Q1 Q2 by R square. The value of K equal to 9 times 10 power 9. Substitute all the values at here. 1 Newton is given there. 1 equal to, since the value 1 is given, K value 9 times 10 power 9, and Q1 Q2 we don't know the values, it's the unknown quantity right now, and R square equal to 0.30 whole square. If I calculate that, simplification, 0.30 whole square divided by 9 times 10 power 9 equal to Q1 Q2. So let me use the calculator. So you can use the calculator. 0.30 square and divided by 9 exponential 9. So the value of Q1 Q2 I got equal to 2, 4, 6, 8, 10, 11. So that I can write as 10 power minus 11 equal to Q1 Q2. So I got the product of the value Q1 and Q2, and I am having one more value Q1 plus Q2. So by using this formula, by using these two values, we will solve it out further. So if you can remember A minus B whole square formula, so that is A minus B whole square equal to a plus b whole square minus 4ab. So this formula I will use it here. So to calculate Q1 and the Q2, I will rewrite the formula as it is in terms of Q1 and Q2. Q1 minus Q2 whole square equal to Q1 plus Q2 whole square minus 4 Q1 Q2. Now plug in the values. What the values we are having? Q1 minus Q2 whole square equal to Q1 plus Q2 7 micro, 7 times 10 power minus 6 whole square minus 4 times Q1 and the Q2 10 power minus 11. So Q1 minus Q2 whole square equal to, if we can multiply, 49 times 10 power minus 12 minus 4 times 10 power minus 11. So Q1 minus Q2 whole square equal to, we can bring it just like similar powers of 10. For that I am writing as 4.9 times 10 power minus 11 minus 4 times 10 power minus 11. So these two powers are same, you can subtract it. I can get 0.9 times 10 power minus 11 is Q1 minus Q2 whole square. And do the square on both sides. For that I can rewrite the expression. So Q1 minus Q2 whole square equal to, this you can write as 9 times 10 power minus 12. It's easy to calculate. So Q1 minus Q2 equal to under root of 9 times 10 power minus 12. Now Q1 minus Q2, solve it. Root 9 times root 10 power minus 12. The final result is 3 times 10 power minus 6 is the Q1 minus Q2. Therefore, Q1 minus Q2 equal to 3 times 10 power minus 6 and Q1 plus Q2 equal to, and Q1 plus Q2 equal to 7 times 7 micro, 7 times 10 power minus 6. Solve further, you can get Q1 value as Q1 equal to 5 microcoulomb and Q2 equal to 2 microcoulomb. By adding these two and subtracting these two, you can just solve these two expressions. So finally you can get the final results of the individual charges, the quantity or the magnitude of the individual charges equal to Q1 equal to 5 microcoulomb and Q2 equal to 2 microcoulomb. Let's see another problem. The problem is a free pith ball A of 8 gram carries a positive charge of 5 times 10 power minus 8 coulomb. What must be the nature and magnitude of charge that should be given to second pith ball B fixed at 5 cm below the former ball so that the upper ball is stationary? So if you analyze this problem, so you will understand there are the two balls, are there two pith balls. Pith balls means just polystyrene small balls. So one is A and this is the free, it means it can move, fall. And another pith ball, it is B is fixed, means it cannot move, fixed, and A having pith ball A of 8 grams. It means this ball mass is given. Mass of A equal to 8 grams and positive charge. So this is having positive charge and charge of A equal to, it's a positive 5 times 10 power minus 8 coulombs. Now what must be the nature and magnitude of a charge that should be given to second pith ball at a distance 5 centimeters? So the distance between them equal to 5 centimeters. That is the distance between them. Now we have to calculate the magnitude and nature of the charge below of A. Task. Calculate magnitude and nature of B. Calculate the magnitude and nature of the B so that the upper ball is stationary. So this is the key point in the problem. So this ball should be stationary. If any object should be stationary, it means there should be two forces should act equally and opposite in direction. So to make ball A stationary, there should be a force should act in this direction and there should be a force should act in the downward direction. Since it's a positive, if B is a positive, then we will get the upward force. So I can guess the nature of the B is positive. And where is the downward force? Since it's the free, it's falling, the downward force equal to gravity force. So here the downward force F equal to mg, mass times gravity. Now the upward force is Coulomb's force. The force F equal to K times Q1 Q2 by R square. Now you just make it equal these two forces. Since your task is the ball A should be stationary, for that you need to equal the two forces. F equal to mg. So F equal to mg and F equal to one more force, upward force is Coulomb's force, K times Q1 Q2 by R square. When the pith ball A remains stationary, when pith ball A remains stationary, we just make it equal these two forces, means K times Q1 Q2 by R square equal to mg. So grab the value of K, its value 9 times 10 power 9, and we know the charge Q1 charge is 5 times 10 power minus 8 coulombs. We don't have the charge Q2, that is our task to find it out. and the distance between them is 5 centimeters. You convert that in terms of meters. 0.05 meters whole square equal to the mass is given in terms of the grams. So 8 grams you convert in terms of the kg. So 8 times 10 power minus 3 times the gravity value 9.8. So if we solve the this following expressions, you will get the final value q2. So that will be the end of the problem and the magnitude of the charge and the nature of the charge. Sure that I won't give this answer, so that you do by yourself by getting the calculation. So here the nature of the charge is positive, that's sure. The nature of charge is positive, and you can calculate the magnitude. So I will give the partial answer, that is in terms of dash dot dash dash times 10 power minus dash coulomb. So this is the end result of the charge. Work it out. Let's solve one more problem, very important and interesting. The problem is, calculate the speed of electron revolving around the nucleus of a hydrogen atom in order that it may not be pulled into the nucleus by electrostatic attraction. So if it is proton, electron is revolving around the nucleus in this hydrogen atom. If it is the orbit, the electron is revolving, negative charge electron is revolving around the nucleus. And we learned that there is a force of attraction between these two. Since it is the positive, this is the negative, the electron will move towards to the positive because of electrostatic attraction. But this force should be balanced by some other force. That's why the electron is not collapsing in the nucleus. So there is a force because of the revolution. So that force you might be guessed. So that is due to because of the centripetal force. So there is a centripetal force between the proton and the electron in a hydrogen atom. The C stands for centripetal, and there is a electrostatic force. Since these two forces are equal, that's why the electron is not collapsing in the nucleus. So to calculate the velocity of the revolving electron in an hydrogen atom, you must make it equal the force due to centripetal force equal to the force due to electrostatic. If you recall the centripetal force formula, mv square by r equal to electrostatic force k times q1 q2 by r square. Here q1 equal to charge of electron and q2 equal to charge of proton. So they both are having the same charge, 1.6 times 10 power minus 19. And r is the distance between the electron and the proton, and here the r is the distance between the electron and the proton. So that is given the radius of the Bohr orbit. So this is the orbit, and if you can simplify this at a moment, 1 of r gets cancelled, and we need to calculate the velocity. So I will rewrite the expression, v square equal to k times, in the place of the charge q1 and the q2, I want to replace the charge of an electron. So since I will write that as E minus square, since they both are having the same charge, charge of an electron, by m comes to downstairs and r remains at here. Now if you can give the under root, that implies v equal to under root of k times e minus 2 square divided by m times r. Just simplify here itself only, because our calculations will make easy. Under root of k by mr times e. One of the root will gets cancelled to the e. So the finally, if we can substitute the values which are given there, velocity v is equal to square root of the value of k 9 times 10 power 9 by mass of the electron 9.1 into 10 power minus 31 kg, 9.1 times 10 power minus 31 kg, and the radius of the Bohr orbit 0.5 angstrom, so it is nothing but 0.5 times 10 power minus 10 meters, and everything multiply with charge of an electron 1.6 times 10 power minus 19 coulombs. Okay, so you work it out for the end result. So you will get the value in terms of the radius of the Bohr orbit and the mass of the electron, and you will get the final value, the velocity of the revolving electrons. So I am not solving the problem at here, so you can do it by yourself. So the velocity v equal to sometimes dash times 10 power 6 meters per second. Yeah, so this is the realistic problem. The electron revolving with a huge speed 10 power 6 meters per second in an orbit around the nucleus in an hydrogen atom.